Good day everyone. In this video we'll talk about sampling. Let's first understand the difference between population distribution and sampling distribution. The population distribution is a probability distribution of a population parameter, while the sampling distribution is a probability distribution of a sample statistic. Let's not get confused between statistic and parameter. Statistic is, for example, the sample mean, while parameter is, for example, the population mean. So when you use the word population, you make sure that you use the word parameter with it, while when you use sample, use the word statistic with it. The central limit theorem, in simple words, no matter what the distribution of the population is, if you do sampling for sufficient number of times, the means of samples will approximate sample distribution. The more samples you extract and the bigger they are, the closer the normal distribution the sample means will be. After few minutes, we will see R application or R demonstration of the central limit theorem. Statistical models or statistical model is a way of simplification of a complex reality to draw a conclusion on population by applying statistical models on a sample from this population. Statistical models are used for description or prediction. Sometimes you may hear the terms descriptive, predictive, and prescriptive statistical models, where prescriptive will recommend an action. Types of model are either parametric, rely on estimation of population parameter, or non-parametric, which rely on ranking of observations. Parametric models are more accurate and precise as they have more statistical power, but they have more assumptions that should be met before building the model. Therefore, better use parametric models whenever the data set meet the assumptions. For every statistical model, certain assumptions must be met to draw accurate conclusions about reality or about the whole population. If these assumptions are broken, you will have wrong statistical model used for data, which will make you draw wrong conclusions. Assumptions of parametric data must be met to assure that data is parametric, and hence use parametric tests and get accurate results. For example, normal distribution of data, homogeneity of variance, and independence. Checking normality can be performed visually or by quantifying the shape of distribution, for example, skewness and kurtosis, and compare distribution to a known normal distribution using Kolmogorov-Smirnov test or Shapiro-Wilk test. The visual assessment of normality by plotting the data, checking a histogram, you will see the famous bell-shaped curve. You can also plot a box plot to detect outliers. One limitation of visual assessment is that it is subjective. You can also check normality through QQ plot or PP plots. We will see how to do it in R in few moments. Regarding skewness, when we say that the data can be skewed, meaning it tends to have a long tail on one side or the other. For example, this tail here to the left is called negative skew, and this tail to the right here is called positive skew, and this bell-shaped approaching normal curve is no skew. Regarding kurtosis, the curve can be mesocurtic or leptocurtic or platycurtic. We will now move to R to check the central limit theorem application, kurtosis, skewness, and checking of normality visually and using QQ plot and PP plot. Let's go.